Welcome to Maheshwari Chemistry classes. Today our topic is atomic structure important bits for IIT JEE means and net set purpose also. Listen carefully. If you like this video, please subscribe my channel and listen carefully. Please give me your support. Listen carefully. The order of increasing energies of the order of follows. For this purpose, first we have to learn Molar diagram. Already I explained in previous classes electronic configuration purpose. That link I can provide in description box. First listen carefully. First we have to check the options. First option 3s 3p 4s 3d 4p. Next 3s 3p 3d 4s 4p. Next 3s 3p 4s 4d 4p 3d 3s 3p 3d 4p 4s. From this we have one conclusion. What is that beta? Only the orbitals are given from where to where? Third orbit to fourth orbit. Okay, so now we have to follow the energy increasing order. Energy increasing order, lower to higher we have to check. Means up to 4d I want to write. Okay, so why? Because ended value is how much, Nana? 4d only is there. Okay, 4p orbital is there. That's it. Here up to here we have to check. 1s 2s 2p 3s 3p 4s 3d 4p. Okay, so according to that, if we check 3s will come first. 3s all have 3s only. Later on 3p all have 3p. After that 4s. So here these are the options. Either it may be first and third. Okay, 3s after 3p, 3p after 4s, 4s after 3d. So this is the 3d. So first option. Automatically our option is 1. This is the energy increasing order. Okay, what is that? 3s 3p 4s 3d 4p. Means 3s less energy, 4p higher energy. That's it. Now next question. After filling the 4d orbital, an electron will enters into the same as it is 4d orbital. After it enter into the 5p. Okay, the option is third. Okay, next, the energy of an electron of 2py orbital is first option greater than 2px orbital, second option less than 2pz orbital, third option equal to 2s orbital, fourth option same as that of 2px and 2pz orbital. What he is asking, in all are p orbitals only. Got it? This is the clue. Okay, so this is px py pz. Already you have an idea. Okay, so listen carefully. An electron py orbital energy, how it is related to the px and py? Is it greater than 2px? Okay, or it is greater than 2p, less than 2pz? How it is? Or equal to s orbital? Okay, equal to s orbital. Our fourth option, what is that? Same as that 2px 2pz. Absolutely right. Fourth option is right. Why? Because px py pz orbitals are degenerate orbitals. So px equals to py equals to pz in energy pattern. Due to that reason, these are called degenerate orbitals. That is why fourth option is same. Fourth option is correct, same as that of 2px and 2pz orbitals. Which one? 2py. So fourth option. So please like this video. Please give me your support. Next, if the electronic configuration of lithium is written as 1s3, then it is against well known s orbital only single shell. Means only 2 electrons possibility. Means only 1s2. 1s3 is not possible. Oh, he only given. So means which rule is against? Is Pauli's rule or Horn's rule, Abbo principle or de Broglie theory? De Broglie equals theory is what is that beta? Relation between the wavelength and what is that? Angular momentum, right? Lambda equals to h by p, like that. So it is not related here. Pauli's principle, Horn's rule. For this purpose, 54 seconds trick I given. Within the 1 minute email on this. Anyway, once again I want to tell the trick. Listen carefully. Above principle, lower energy orbital first fills, higher energy orbital next fills. Lower energy first fills. Horn's rule. What is that Horn's rule? Either 0 either half, either full filled. Nothing but empty, half, full filled orbitals are highly stable. This is the second step. But what is our first step? First sharing. Okay. Next pairing. This is Hund's rule. Pauli's exclusion principle. In a single shell, only 2 electrons possibility is there. These 2 electrons are not equal for 4 quantum numbers n, l, m, s. Now, which is correct option beta? First option is right. According to Pauli's principle, in one box, in your words, but actually in one subshell, okay, only only 2 electrons possibility, more than 2 not possible. Here more than 2 given, 1 is 3 given, so that is why it is not following, it is violating the Pauli's principle. Okay, that is why option 1 is right. Please like this video, please give me your support. Next, the presence of 5 unpaired electrons in 3d orbitals of manganese atom. According to manganese atom purpose, we have to check beta manganese purpose. Okay, so what is that valency shell? If you check now, 3d orbitals, what is that 3d orbitals, 3d orbitals purpose, that is 4s0 will have a 3d5 may have. Okay, so according to that, how many unpaired electrons are present? Here manganese atom given directly, so 4s2 3d5 we will take. So here automatically d5 means according to which rule? According to Hund's rule. First sharing, next pairing. 5 unpaired means 5 single electrons, right? So 5 single electrons, that is why it have a higher Bohr magnetic value. So which principle it is following? Pauli's principle, Hund's principle, Bohr principle, or de Broglie theory? Yes, once you think better. Yes, your answer is right. Hund's rule. First sharing, next pairing. D5 definitely it have like a 5 unpaired, 5 single electrons. So option 2 is right. Next, the orbital diagram in which both Pauli's and Hund's rules are violated. Some orbital diagrams given beta. Once you check here, s orbital single electron, p orbital px purpose 2, same side direction of electrons given. This is the electrons. Both Pauli's not following, Hund's not following. Okay, which one beta? This one. Pauli's purpose, what is that beta? First lower energy orbital fills, next higher energy. But lower energy orbital not filled, even the electron enter into the higher energy. Compared to the s, p is higher energy, right? So it entered, nothing but it is not following Pauli's principle, Hund's rule. Okay, so Hund's rule, don't forget. Okay, Hund's rule, first sharing or next pairing, but here not shared equally, even though pair up occur, nothing but it is not following Hund's rule also. So that is why first option is right. Next question, which among the following degenerate orbitals of d is different with others? Okay, either dx square y square, or dxy, or dz square dzx. Only dz square is different beta. All these two, I mean 1, 2, 3 option purpose, all have two planes, either xy plane or a zx plane, but only dz square have a z plane only, and that z plane lobe is present and circle is present, that is why it is different. So option is the third. Okay, dz square orbital is different compared to the other d orbitals. Okay, other suborbitals. Okay, I think you have an idea, even the ones I want to tell. Listen carefully. This is dxy, this is dyz, this is dzx, dx square minus y square, this is dz square. It is different for orbital diagram purpose only, but energy same, that is why degenerate orbital. Don't forget, degenerate orbital, energy same, even though it is different. Okay, on plane wise. Next, The correct order of magnetic momentum values for the following: chromium 3 place, copper 2 place, zinc 2 place, nickel 2 place, iron 2 place, manganese 2 place. For all these purpose we have to write electronic configuration beta. According to that we have to fill electrons in valency shell. So based on that we have one trick, right? If one electron is present, for example this is the d orbital, if one electron is present, so automatically Bohr magnetic value will come, for example 1.73 or 1 something, so that is by 1 bm we have to take. So copper plus purpose, here 3 lone pairs possible, that is why the value may be 3.8 Bohr magnetons. Copper 2 plus purpose, only one electron, single electron possibility is there, that is why 1.73 Bohr magnetons. Next zinc 2 plus purpose, there is no single electrons, that is why 0 bm. Okay, next nickel 2 plus purpose, 2 single electrons possibility is there, that is the value 2.83 Bohr magnetons. Next iron 2 plus purpose, 4 single electrons possibility is there, that is why Bohr magnetic value 4.90 something. Next manganese 2 plus purpose, highest 5 single electrons are present. Okay, the value may be 5.9. According to that simple, just you have to remember here single electrons, unpaired electrons, so we have to take like a Bohr magnetic value. For example, if it is one electron we have to take 1 bm, 2 electrons we have to take 2 bm. This is the trick beta. Okay, so based on electrons number we have to decide Bohr magnetic value, nothing but magnetic momentum value. Chromium plus purpose 3 lone pairs, that is why value 3. Copper plus chromium purpose 3 single electrons, value 3 bm. Copper purpose 1 single electron, value 1 bm. Zinc no single electrons, that is why 0 bm. Bm means Bohr magnetic momentum value. Nickel 2 plus 2 single electrons, the value is 2.83. Fe2 plus purpose 4 single electrons, the value 4.9, nothing but 4 we have to take. Manganese purpose 5 single electrons possibility is there, that is why Bohr magnetic momentum value how much, 5.9 Bohr magnetons. This magnetic momentum value units is a bm. Okay, so now according to this we have to write the order A, B, C, D, E, F. In this which is correct? Some options are given. A purpose chromium, B purpose copper 2 plus, zinc purpose C option, nickel 2 plus purpose D option, E in A option Fe2 plus, F option Mn 2 plus given. So which is the correct option beta? C is the correct, third option is the correct. Okay, so that's it. Okay, nothing but zinc 0 will come first, after that 1, nothing but copper. Okay, next after that D, here nothing but nickel 2. Next A, that is 3 chromium purpose, after that E, that is iron 4. Next F, that is manganese 5, right? 0 1 2 3 4 5, 5 highest, 0 least. According to this chromium to manganese, this is the order, so option 3 is the right. Okay, so if you like this video please subscribe my channel. అసలు ఇన్నిసార్లు అడగాలంటే నాకే ఇలాగా ఉంది, కానీ ఎప్పటి నుంచో వీడియోస్ చేస్తున్నాను, సబ్స్క్రైబర్స్ అయితే ఉన్నారు కానీ ఆ వ్యూస్ లేవు. కొంచెం మీరు మీ ఫ్రెండ్స్కి ఫార్వర్డ్ చేయండి, ఓకేనా? డబ్బులు పెట్టి ఐఐటి కోచింగ్ వెళ్ళలేని వాళ్ళకి హెల్ప్ అవుతుంది, మరి ముఖ్యంగా పల్లెటూరు పిల్లలకి హెల్ప్ అవుతుంది. ప్లీజ్ వీలైనంత ఎక్కువగా ఫార్వర్డ్ చేయండి, షేర్ చేయండి. ఓకే, నెక్స్ట్ క్వశ్చన్. ద మ్యాక్సిమం నెంబర్ ఆఫ్ అన్పేర్డ్ ఎలక్ట్రాన్స్ ఆర్ ఇన్ Fe3 plus, Fe2 plus, Fe and Fe4 plus. ఓకే, dead easy. What is that? Fe3 plus only maximum number of unpaired, nothing but maximum number of single electrons possibility. That is why option 1 is right. First we have to write electronic configuration and we have to check how many single electrons present. Okay, so if we check Fe3 plus have more single electrons. Next question. The magnetic momentum of metal ion of transition element is 2.83. Therefore it will have unpaired electrons, nothing but single electrons. Now only I will write. So unpaired electrons, nothing but unpaired electrons, nothing but a single electrons. This is the trick. How many single electrons possibility? Same amount of more magnets will come, nothing but here magnetic momentum value 2.83 given, so automatically according to our trick, how many single electrons possibility? 2 single electrons possibility. So this is the trick, you have to remember, 100% workout aye trick idi. So option 4 is right answer. 2 electrons is right, 2 single electrons. Okay, next 50th question. The number of unpaired electrons are there in nickel 2 place. Nickel 2 place లో ఎన్ని unpaired electrons ఉన్నాయి? ఐ మీన్ ఎన్ని సింగిల్ ఎలక్ట్రాన్స్ ఉన్నాయంటే 2. సింపుల్, మనం రాసుకుందాం ఒకసారి, మీకు ఏమైనా డౌట్ ఉంటే చూడండి. ఓకే, నికెల్ కాపర్ జింక్ కదా, నికెల్కి 28 వస్తుంది. నికెల్ 2 ప్లస్ అన్నాం కాబట్టి 26 ఎలక్ట్రాన్స్ తీసుకోవాలి. అకార్డింగ్ టు దట్ ఇఫ్ యూ రైట్ 1s2 2s2 2p6 3s2 3p6 4s1 4s2 3d6 we have to check. Okay, if I write only d orbital, okay, in this d orbital first sharing and next pairing 1 2 3 4 5, after that like this. But here we have to check, nana, from this s orbital towards d orbital electrons are shifted. Now it is coming as 0. Now here 2 pairs will next only 2 single electrons possibility is there. Okay, 1 2 like, okay, this is the condition first. From this s orbital these 2 orbitals also filled, only 2 single electrons possibility is there. Okay, so that is why yes, 2 single electrons possibility, that is why our option is 1. ఓకే, ఈ ఆప్షన్ నెంబర్స్కి ఆన్సర్ నెంబర్స్కి కన్ఫ్యూజ్ కాకండి. ఓకే, థ్యాంక్ యూ ఫర్ యువర్ పేషెన్స్. థ్యాంక్ యూ. Please give me your support. Thank you.